Here we have two questions that have the same prompt. Do the following lengths form a right triangle? Now, for number 1, we have side lengths of 6, 8, and 9. And for number 2, we have side lengths of 5, 12, and 13. Just from looking at the numbers and the side lengths, I know that number 1 is no and number 2 is yes. There's a reason for this, and it's not just because I'm the one that is doing the problems and making this video. Now we can prove this by using the Pythagorean Theorem, which is a relationship that was found by the mathematician Pythagoras that relates three sides of a triangle to each other. Now, I'm sure we've all heard it before, but the Pythagorean Theorem, if we need a refresher, basically amounts to a squared plus b squared is equal to c squared. Now, if we have a right triangle, and this is the right angle, the two sides that quote-unquote touch the right angle, such as this side and this one, are known as the legs.
Let's go, Ian. Finish up in there.
And the side that's across from the right angle, so this one, is known as the hypotenuse. So when we talk about the Pythagorean theorem, these are the legs, and let me move this down just to make a little bit more room for myself. And C is the hypotenuse. So what we're really saying is that when you take the length of the legs, square them, add them together, and then take the hypotenuse and square it, those two, so the sum of the two legs squared and the sum and the hypotenuse squared, should be equal to each other. Okay, there's a reason for that. We won't get into the proof now, but we can use this theorem to then figure out whether it forms a right triangle or not. And if this is true, because any equation is just a math sentence, if the math sentence or the equation is true, then it forms a right triangle. So let's take a look at number 1 here. And let me move this Pythagorean theorem a little bit over to the side here. So let's take a look at number 1. So we have what kind of looks like the right angle over here, and we have side length 6, 8, and 9. And we can sort of assume as well that the 9 is the longest, or that it's the hypotenuse because it is the longest. And the hypotenuse is always the longest side in the triangle. So, that being said, we know that 6 and 8 are our legs. So, we can set up our Pythagorean theorem and then plug in. So we can call this one A, this one B, and the hypotenuse is always C. So let's substitute. And then when we solve for the exponents and complete, we have 36 plus 64 is equal to 81. And then once we do the math here, we have 81 on this side, and we have 100. Now, 100 is not equal to 81, so it is not a right triangle. Now for number 2, we can pretty much do the same exact thing. And it's oriented the same way. So this is a leg, that's a leg, and that's the hypotenuse. And it doesn't matter which leg is A or B. It could be either one, and that's due to a property known as the commutative property of addition. In other words, it doesn't matter which order you do them in because we're adding them together. And adding you can do either way. So let's plug in our Pythagorean theorem and then substitute our numbers. 5 plus 12 squared is equal to 13 squared, and that's 25 plus 144 is equal to 169. And then once we finish our addition, 169 is the same as 169. So, yes, it forms a right triangle. Now, remember how I said that I just know that number 1 and 2, I know the answers, and that's because of the Pythagorean theorem. There are certain almost famous whole numbers known as Pythagorean triples, where if you go in order and name them off, they always form a perfect right triangle. So, one of the most famous ones is this triangle, 5, 12, 13, where the side lengths are 5, 12, and 13. That always forms a right triangle. Another famous one is 3, 4, and 5. And these are Pythagorean triples. And these are exact whole numbers that will always form a right triangle. Now, it seems awfully close, but if we multiply this out by 2, so each of the numbers is by 2, we get 6, 8, and 10. Now, we almost had that up here in number 1. We had 6, we had 8, but because this did not satisfy the triple, which is the 10 down here, I knew that it could not form a right triangle. There are a bunch of these, but 2 of the most famous are the 3, 4, 5, and of course, whenever you multiply it out, so 3, 4, 5, there's also 6, 8, 10, and 9, 12, 15, so on and so forth. There's also 5, 12, and 13, or 10, 24, and 26, or 15, 36, and 39. And that's just multiplying by 2 and then by 3 for the 3, 4, 5. And the 5, 12, 13. So that arrow should actually be going there. Times 3 and times 2. Now you don't always have to just know the Pythagorean triples, but it is a good idea just to know. And you can always prove it by using the Pythagorean theorem. I hope you learned something new. Thanks for watching.